Hi, welcome back to Statistics class. Our topic for today is about the test of association and independence. Specifically, we will talk about the Spearman Rho. This time, we will introduce to you the Spearman rank order correlation, and we will talk about and discuss the Spearman rank order correlation coefficient formula, and then we will have one example and do the hypothesis testing. Okay, so person R coefficient, if you could recall in your elementary statistics, it describes the strength of association between the bivariate data X and Y, or your two variables. And this person R coefficient, this statistical techniques is referred to as a parametric method because it lies under the assumptions of normality. However, in our topic today, it is the non-parametric method. Then the non-parametric counterpart of person R correlation. So these non-parametric methods, if you could recall, have been developed for conditions in which the assumptions necessary for using parametric methods cannot be used. And so this Spearman rank order correlation or Spearman rank order coefficient of correlation denoted by RS in contrast with the person product moment coefficient of correlation or the person R. So like the person techniques, the Spearman Rho or the Spearman rank correlation, it shows the relationship between the two variables. So the person correlation is used for continuous or ratio data and must meet certain parametric assumptions. However, in the Spearman Rho or Spearman rank order correlation, it assumes only that participants were randomly selected, scores are independent of one another, and the relationship of one score with another is monotonic. So the utilization of this statistical method is of prime advantage when quick preliminary indication of results is needed because computations can be performed speedily. So, in other words, to summarize it, Spearman rank order correlation, the Spearman rank order correlation coefficient known as Spearman Rho with this with this symbol is the non-parametric alternative to the person product moment correlation coefficient or the person R. So if you are using the parametric method, you use the person R. If you are using the non-parametric method, especially because of your methodology, then you use the Spearman rank order correlation coefficient or the Spearman Rho. So RS is a non-parametric method of determining the strength of relationship between two variables when it is not necessary to assume that the observations are normally distributed. So if your data is not normal, it does not meet the assumptions of parametric method, then you have to use the non-parametric method, which is the Spearman rank order correlation, if you want to know the strength of the relationship between the two variables, and appropriate for dealing with data that are measured on an ordinal scale. So remember the level of measurement. We have the nominal, the ordinal, ratio, and interval. So if your data is measured in ordinal scale, then Spearman rank is appropriate to your data. And also, computations can be performed speedily. So, to obtain the value of Spearman rank order correlation coefficient denoted by RS, because if you are using only R, then it symbolizes the parametric method which is the person R. But if you are using the Spearman rank order, then you use RS. Okay, and then let us follow these steps. So step number 1, you have to rank the X values from highest to lowest. Example, you have two variables. Let's say the height and the weight. So the height, you can note that as an variable or your x data, and then your weight will be y. So it depends on your study. So first step is rank the x values from highest to lowest. And then the highest value is given the rank of 1. And then the second highest is 2, and so on. So let this column be Rx. And then we have to repeat step 1 for the y values. You arrange it ascending and then label this column as Ry after you rank it. And then determine the difference in ranks for each pair. Example, Rx minus Ry. Then label this column as D. And then, after that, step 4, square each difference to fill up column D. So your value in D, you square it, then it becomes your column D squared. And then, get the sum of the D squared column. So solve for the Spearman Rho using this formula. Rs is equal to 1 minus 6 multiplied to summation of di squared, where I ranges from 1 to n, over or divided by your n cube minus n. So where Rs is your Spearman rank order correlation coefficient, and d squared is the square difference between paired ranks, and n is the total number of pairs or your population size. So like the Pearson correlation coefficient R, Spearman rank order coefficient or Rs is also takes the values from -1 to +1. So interpretation of computed R values can also be used to interpret computed Rs values. So similarly, Rs value close to positive or -1 indicates a high correlation, and those values close to 0 suggest lack of relationship. So in other words, if you want to know the strength of the relationship, it is only between -1 to +1. So there will also be 1. So that is perfect relationship. So always remember that there is no strength of relationship more than 1. So we can use their interpretation of our values. So if your values is between 0 and 0.2, then that is very weak relationship. If you're talking the height and the weight, okay? So if we have the two variables and then your data falls or your coefficient falls into this value, then they have the very weak relationship. And then if your values is between 0 0.2 to 0.4, that is weak relationship. Just a descriptive interpretation. And then 0.4 to 0.6, you have the moderate relationship. And then if your coefficient falls in the values of 0.6 and 0.8, then you have a strong relationship. And then if your values is between 0.8 and 1, then you have a very strong relationship. If you have a 1.0 coefficient, then you have a perfect relationship describing your bivariate data or your bivariate variables or your two variables. And advantages of using Spearman rank correlation. Underlying linear relationship of x and y variables are not assumed. And when the data possess a distinct curvilinear relationship, the rank coefficient will likely be more reliable than the conventional measures, say, Pearson R. And no assumptions of normality are made concerning the distribution of x and y. Perhaps the greatest advantage occurs when one is unable to make numerical measurements but, nevertheless, can establish rankings. For example, when different judges rank a group of individuals according to some attribute, the rank correlation coefficient can be used as a measure of the consistency of the two judges. So, for you to better understand it, let's have some example. Example, we have these 6 students. So the final grades on English and Filipino of 6 CPAC students are shown below. Can we conclude that there exists significant relationship between the student's grade in English and Filipino? So if I am the student number 1, and then I have the grade in Filipino 89, and then my grades in English is 97, and for the rest of the students until to the 6 students. And then step 1, I have to rank my x data, my variable. So the rank 1 is 93. So I have put here 1. So the second rank is 91 from highest to lowest, and but then the rank is 1, 2, 3, and so on and so forth. So this column is Rx. Then I will do the same for the Y variable, or the my grades in English, or the student's grade in English. Then rank it again. Then after that, I have to take the difference. So 4 minus 1 is equal to 3. And then I will square it. So 3 squared is 9. And then 6 minus 6 is 0, squared 0. And then 1 minus 4, that is negative 3, square it, that is 9. And then 5 minus 5 is 0, square it. So, and then after that, we have to sum it up. This d squared, summation of d squared is equal to 18 because 9 plus 9. Then after that, using the formula that we have for Spearman rank correlation, we have 1 minus 6 multiplied to the summation of di squared, where I ranges from 1 to n, over n cubed minus n. So of the value that we have here is the summation of di squared. So we have sum it up. So this is 18. So substitute the d squared here in our formula. So 1 minus 6 times 18 divided by 6 cubed over 6. Why it is 6? Why this is number 6? Because we have the 6 students. Okay, that is their population size. So 6 cubed minus 6. So is equal to, again, 1 minus 108 over 210. So by simple calculation, our coefficient, or our Spearman Rho value is 0.48571, or approximately 0.49. So now we have to use the descriptive interpretation for 0.49. So you have to look at it at what level interval the strength of the relationship. You have to figure out if it is strong or weak relationship, but we cannot say that that relationship is significant or not. We can only describe the relationship as strong, as weak, very weak, but using the Spearman Rho, we cannot conclude that there is a significant relationship. Though they may have a strong relationship, but we have to test if it is statistically significant. So after getting the R value, or the Spearman rank value, you have to proceed for hypothesis testing to know if there is a statistical significant relationship between our variables. So using our steps to hypothesis testing, first step is to state your null and alternative hypothesis. So we have to test if our rho is statistically equal to 0. Or we can state our hypothesis this way: there is no significant relationship between grade in Filipino and grade in English. And then our alternative hypothesis is rho is not equal to 0, or in statement form, there is a significant relationship between grade in Filipino and grade in English. And then our level of significance is 5%. And then using the formula of Spearman rank order correlation, we have computed this. Rs is equal to 0.48. And then we have to proceed with the critical region. So we have also the tabular values for Spearman rank, where we could base our decision. So here's the decision rule for Spearman rank. Reject HO or your null hypothesis, if absolute value of your RS is greater than R alpha divide 2 because it is two-tailed, and the corresponding sample size where in our computation where absolute value of RS is equal to 0.486 and our R values, our tabular value is 0.5 divide 2, that is 0.025, and then 6, our population size, we have 6 students, is equal to 0.886. So since absolute value of RS is less than 0.0 R tabular, hence we fail to reject HO because the value, this is our decision rule, because it is not greater. Okay, so 0.48 is less than 0.8, or rather 0.4 is less than 0.8. So how do we get this value? So looking on the Spearman rank tabular value, we have here the 0.0886 because we have the N, the 6 students, and then the corresponding level of significance. We have 5%, but it is two-tailed. So we have 0.025, and so our value, our critical value, is 0.886, where we can declare our decision, our statistical decision. So this is how we should write our critical region. Reject HO if absolute value of RS is less than the tabular value R alpha divide 2, comma, n, where our absolute value of our Spearman rank coefficient is equal to 0.486 and our tabular value in a two-tailed test of 0.05 divide 2, 0.025, 6, n is equal to 0.886. So absolute value of our since absolute value of our Spearman rank coefficient is less than or 0.0256 or tabular values, hence fail to reject HO. So our decision here, we missed it, fail to reject HO. Then the conclusion, the moderate relationship, because 0.048 is in the interval of moderate relationship, but we have to figure out if it is significant or not. So the moderate relationship between students' grades in Filipino and English subjects are not statistically correlated with each other. This means that there is no significant relationship between grades in Filipino and grades in English subject. So even in data, we are really interested to figure out the underlying relationship. So, and then after that, not just quantifying it or having to know what's the level of the relationship, and we also proceed with the significance test. So, we are doing that in statistics. How much more, dear students? We have to learn that it is similar with our relationship with the Lord, our obedience to the law of God. Reminder, or you may have this quote from Ellen White that says, genuine love to Jesus Christ will lead directly to hearty obedience of all the law of God. The more we love Jesus Christ, the more it is correlated to the obedience of the law of God because we have a significant relationship with our Lord. So that's all for today. Thank you and God bless you, dear students. See you in our next topic.